Hmm. I cannot hear myself. Oh, there we go. Okay. Mm-hmm. Where do we leave off? Mm-hmm. Burst balloons. This one will take a while, I feel like. It's quite a complicated algorithm. Yeah. I don't even know if I can do the DFS solution. Like, this is DFS, right? What? Oh, sorry, I got distracted. DP, burst balloons. Yeah, it's a DP problem. So, there's probably a tabulation method for this. So, I guess I need to learn both. Mm-hmm. Something like that. Whoops. This is tricky. This is so wrong. Oh my gosh. Fix something with the settings. Who would be calling me? Settings. Manage channel. Settings, community defaults. That's not it. Unit default. Advanced settings. What the heck? Studio. Let's see. Studio. God. Settings. Community. Comments are on. No comment moderation. Let's try that. the heck? What's wrong with the stream right now? Comments. Oh, did not mean to get rid of that. What the heck? It's whatever. I'll figure it out later. Okay. DFS. There's like numbs. This is totally wrong. Oh, actually, let me. Oh, I can't test that. I need to test one thing for my stream. Give me just a second. Okay. Okay. We're not distracted anymore. Yeah, to be honest, I don't know how to do this. I'm getting very distracted. So we need to stop getting distracted. Okay. It is a table. It's a table with it's a square. Why is it a square? I had the right idea. So it's what? This doesn't seem right. I think it's just the... Oh, okay. Okay. What the heck's going on? Why is it just nums not length? Whoops. Yeah, that makes sense. I was thinking about it wrong. Wow, okay. So how the heck does this work? Okay. Each balloon at position I contributes to the score by the value nums times I. Yeah. Where left and right represent the boundaries. The goal is to find the optimal order of the bursting these balloons. Okay. Nums left, nums right, plus 1. The max coins method? You mean DFS? Oh. The method uses memoization to avoid redundant calculations. Okay. To clear the solution is a recursive calculation where each possible position I in the range left to right. The balloon at position I is considered the last balloon to burst in the subarray. The coins collected from bursting that balloon I are calculated as coins and nums. Yeah, that makes sense. And the neighbors, if left are out of bounds, those terms are ignored. Wait, low key, I think I get it. So we're going to do DFS on this. And this is going to keep on recursively calling. Oh, I wish I could see the call stack for this actually. That'd be crazy. Basically, it's going to end at, like, it's going to say, okay, 3 is the last number we're going to check. So we multiply 3 by 1, and then after that, it's like, okay, we have the remaining, I think, oh yeah. Is there a good way of even thinking about this? Oops. Big oops. Okay. Recursive calculation, divide and conquer. Yeah, I know the premise of it is like, instead of thinking, oh, I need to burst this, and then add this, and then add the one here, it's like, what if I bursted the last one, and then built up to the full array? So like, what if I bursted 8, then bursted 3, then bursted 5, then 1. So the max would be bursting 1 first, 5 second, 3 third, and 8 last. But how would we get there? Bro, I need a guy to go into like explain this in paragraphs. Mm-hmm. Mm-hmm. How does this reduce to the last? Okay. Two dummy balloons with each one. Oh my gosh. This is such a good visualization. But oh, these pointers are at the very end, so the first iteration will never hit these anyways. That's so genius. That's where I was confused, because I thought the first call these would trigger, and I'm like, that's not really calculating the last one. That's like calculating the first one. So this window is like here. And then as we go, as we go, we expand a little bit, expand. I don't think I need to worry about all the subproblems that don't matter though. Oh, this diagram is godly. Wow. Oh, and then it includes that. Oh my gosh. 7, 7, 7, okay. Okay, so the call, the DFS call that will get us all the answers will start at the last one that's popped. It literally is a bottom-up solution. Wow. Dude, who thought of this? Who thought of this? So it'll hit like, okay, in our example, it'll see 8. So it'll run DFS on this, run DFS on this, run DFS on this. Yeah, it'll run through the entire, all the numbers. And then it'll see 8 and be like, okay, let's run everything on 8. And then it'll see 3 and it'll be like, okay, let's run everything on that. And then it'll see 5 and it'll say, okay, let's run everything on that. And then 1, and that just happens to be the biggest one. So if we visualize it, 3, 1, 5, 8, it'll be 3, 1, 5, and 8. Eight by itself, then it's 3 and 1 and 1 by itself. Right. Oh no. Let's run that back. So which is the first one that we pop? 1. So it'll be 3, 5, 8, 3, 8, and then 8. But it really goes the other way. Does it go the other way? Yeah, it says it sees 8 and it's like cool, and now it reverses the next one. It says 3 and it's like cool, and then it reverses the next one, and it sees 5 and it's cool. I don't have a good way of explaining this though. That's the thing. Let's rewrite it and see if I can explain it from there. So we're gonna have a table. And then I'm gonna run DFS on nums table left and right. So if left is greater than right, we're going to return 0 because there are no more balloons to pop. If the value in the table has a value, we're going to return that value because we've already calculated this subproblem. And then we're going to iterate through all the array, get the current number, and if left minus 1 is greater than or equal to 0, close times equals. Okay. So when we start this, we're using the entire bounds of the array. So we're basically constricting the array, this value, or any individual value, but for our purposes, the 8. We're constricting it so that each of the borders is 1. And then we're going to add the subproblems. Okay. Which is fine. Okay. Oh my gosh, this solution is so genius. So, okay, so, wow. Okay. So let's just do the happy path right now. So we're gonna loop through 3. We're gonna loop through 3. It's gonna give us an answer that isn't the solution. We're gonna loop through 1. It's gonna give us an answer that's not a solution. We're gonna do the same for 5. When we hit 8, we're going to run. Oh shoot! We're going to run these checks, and they're going to have the borders on them. And then we add the left subproblem and the right subproblem. Now the right subproblem, I is already 3, right? So I plus 1 is going to make left greater than right, which will exit this condition. So this will effectively be 0. This will be 0. Then the rest, it will say, it'll run this. Okay. And then it'll run this left subproblem on this array. But it'll just do the same thing. So it'll check 1, 2, 3, and it'll say, okay, this is the greatest of them all. So then it'll run this problem, and then it'll do 1, 2, and then it'll realize, oh, this is the greatest of them all. And then it'll run this, and it'll realize that's the last one, and multiply that against these two. Because our bounds by the time we get there. So let's think about our bounds. Our bounds here, our bounds here are 1 and 1. When we get to here, our bounds are 1 and 8. When we get to here, our bounds are 3 and 8. Yeah. And then when we get to here, it's 3 and 5. Wow, genius. Oh my gosh, that's so smart. So we're just breaking up the subproblems and loosening the constraints of pointers. So there are effectively pointers. When you start, there are pointers on the very ends, and then we slowly creep in the window and loosen the restraints on the pointers. And those pointers are left and right. Wow. Okay, let me do this one more time. And then for the reason why I said it was genius again was because this, just how it's positioning the array is pretty genius. I wonder what the array looks like. 5. What does the table look like at the end of the algorithm? Yeah, I do wonder what the table looks like. To be honest, GPT is probably too dumb to figure that out. But yeah. Bruh. Yeah, so it's going to realize it's 3 because this is the position of the 8. Genius. Okay. Yeah, okay, there has to be a faster way to do this. Is there a more optimal solution to this problem? Isn't there like a strictly okay, let's see what these guys are getting. Okay, so this is the same thing. Bro, like this. What is this? It looks like there. Let's see if this works. Hard coding the final value? Wow, okay. So n plus 2 base cases, I guess. Create a new array with the additional ones at both ends. Oh, okay. Okay. DP table. So we're not iterating both ends. 4 left, okay, right. Left plus length minus 1. What's the length? Where did this length come from? Oh, length. Interesting. So it uses the iteration to determine length rather than position in the array. Let's see if they can GPT explain it? Okay. It's a new array with padding. That makes sense. Left and right. So, oh, it's plus. For each subarray, the algorithm considers each balloon as the last one to burst. The coins collected from bursting are calculated and the maximum is updated in DP left to right. Oh, so I guess it's the same thing. Rush. That's actually not too terrible. Oh, yeah, it's doing the same thing. Why do length minus... This is my question. Like, I feel like there's a cleaner way to write this. Because the first one, when the length is, why don't we make it so that it's not length minus 1? Why do we have to have length minus 1? And then just stop it earlier. Maybe I'm probably being dumb about this. Okay. Okay. Okay, that makes sense. This is tricky. I got like 10% of that. Oh, my knee. Ow. Table. Oh, and coins, right? Dude, that's how tired I am. I don't really know how that works. Going to be completely honest. It just seems like a lot of random. I get it. I just n minus length plus 1. Why would we do that? So the reason why we do that. The reason why we do that is to keep the left bound within the length of the subarray. So there's a point where yeah. So the first, this won't even run the first iteration because n will be 3. So it has to be, or it won't run the last iteration because it'll be like 3. Interesting. I really don't want to figure this out. this one's really complicated because there's so many like 1, 1, less than or equal to, less than or equal to, minus the length plus 1, minus 1, less than or equal. Well, this makes sense. And then you have like the new array that you have to make. Man. Fundamentally, it's the same. It's the same time complexity too. Yeah, if it's the same time complexity, I don't... Is there much value in relearning it? Okay. I'm not gonna lie, I'm sick of this problem. So I'm going to add it to the bottom. I'm not gonna not do it. I'm going to do it. I just I don't want to do it now. Yeah. Yeah, okay. Because I already spent an hour. Well, to be honest, I was fixing the stream for a little bit, but I was spending a lot of time on this one freaking problem. Yeah. Okay. Since I've spent so long with it, I'm going to do these. And then we'll do merge intervals if we have time. Oh my gosh, I run into this freaking problem. See, the problem that I'm running into right now is that, like, I can think my way through why this works the way it is, but the only way I was able to, I've just memorized that this is the way it is. Yeah, unfortunately. So let's explain it. So cooldown count is the number of cooldowns that we have. So we'll take the max frequency and we'll subtract 1 from it because we'll have 3 A's and we won't need to idle the last A, or we won't need to have idles for the last A because there's no A preceding it and we don't need to wait. Cooldown length, we have to take the max frequency count, so the number of values that have the max frequency, and we have to subtract 1 from it because we basically have placed all the A's in this situation. So now the cooldown length doesn't include that A because we've already placed it, right? So we have to subtract 1 from it and then subtract it from the cooldown length that we are given. Yeah. Okay, we got that. So I'm still not comfortable with it though. Like I still have to think about it. I don't know if it's good that I want to get to a point where I don't think about it though. Okay, let's do both DFS and tabulation here. So we'll start with DFS. Cool. Let us tabulate now. Mm-hmm. Wow, 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 wow. Okay. Nice. Nice, 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 nice. What's next? Distinct subsequences. Wait, do I have to redo that? Yeah. Oh my gosh. Oh my gosh. No way. Okay. No way. What am I doing wrong? Is it +1? What am I doing wrong? I doubt it's -1. It actually would not make sense if it was -1, in my view. Yeah. I'm not iterating somewhere. So I was thinking about putting +1 here, but the whole point of having this is because we're adding. Whoa. I'm just resetting it too. I feel like to avoid an extra line, we do this. I just throw this in here. I believe that's shorter. Yeah. Okay. Now, how do we do the other tabulation method? So, I'm not gonna lie, I didn't think I was gonna get that one. Okay, nice. I think, cause I don't think I have enough time to go through a full problem. We'll just do some random problems. What should I do? I know all these. Most of the heaps I don't know. Yeah, like, what should I be doing? Yeah, what should I do? Okay. I have 7 minutes before I want to wind down. You think I could do the whole list? We'll see. That's not a good start. Yeah, that was a terrible start. Okay. Okay, I think I was overly ambitious with the 7 minutes thing. What? Wait, what? Memory limit exceeded for this. Do I have an infinite loop somewhere? That would be time limit. What am I doing wrong? This is embarrassing. I'm scared to look at the answer. I don't know what I'm doing wrong. This looks identical to what I have. Let's ask GPT. That's crazy. What am I doing wrong? Does this, oh. Bro. I also didn't know you could do it without doing that. Okay, let's see how many more we can do. That was terrible. This is also like a terrible problem to like try to speedrun. No. I'm kind of disappointed. That was crazy for me to think that I could do all those problems in like less than 7 minutes. I will not lie. Okay. Today was a tougher day for sure. I mean, we got through this, but verse balloons took quite some time, and then I had some stream issues, which, to be honest, is a little bit my fault. No, it's completely my fault. But no, burst balloons. I mean, like I didn't even get to the I didn't even get to the second solution. So yeah, that took a while. I am also quite tired, but I did want to stream. That's not an excuse, even though I just made it one. Yeah. So hopefully we can do better than today. Yeah, burst balloons just took a while, and then yeah, quite unfortunate, but you know, we got a long weekend ahead of us for sure. So yeah, we'll get a lot done. Yeah. Until the next time, which will be tomorrow. Yeah.